Hello everyone, welcome to P for Physics, and this is Joe. So this will be a portal where you happily learn physics. Let the joy of learning begin. So before jumping into the introductory part, let me tell you that I'm going to follow the textbook of TNSCERT, Tamil Nadu State Government's textbook. So in the description you can see the link where you can download the ebook version of that textbook so that following these classes would be easier. So here we would give importance to understanding, and there would not be hurry. There is no need to be a hurry. So we will just go on with the flow. So the 12th standard physics of TNSCERT textbook comprises two volumes, volume 1 and volume 2. So in your 11th standard, irrespective of the textbooks that we follow or the streams that we are following, the basic concept of physics is going to be the same. High school physics, that is how we popularly call the basic physics content as. So in the high school physics, you would have learned a part in 11th grade, and now you are in 12th grade. So in the 11th grade, if I could just give the title in common for the entire 11th standard syllabus that you have studied, we would call it, or we could call it by a single name. We could give it only a single tag. We might call that as classical physics. The classical physics is also called Newtonian physics by some people. That is also a popular name for it. So classical physics or Newtonian physics. So this is the name that you could give for the entire 11th standard syllabus. Right from starting from the measurements, dimensions and all that, and till the wave motion that you have studied in the later part, all of that can be said to be Newtonian physics or classical physics. But though I am able to give a single title for the entire syllabus of 11th grade, you cannot just club them together because they were like islets. Yes, I mean. So they were like islets because when you learn about gravitation, it is totally different from the thermodynamics that you learn later. The kinematics was entirely different from this thermodynamics. So they were like islets. So when we talk about those topics are just introduction to different fields of physics, where everything comes under one branch, one umbrella called physics. Physics, of course, is a part of a science on a broader spectrum. Less. So if I want to give a title, common title for volume 1 of this 12th grade, how would I give it? Yes, Electromagnetism. So Electromagnetism is a single title that you could give for the entire volume 1 of your 12th grade physics. And if I want to give a title similarly as I have given it for volume 1, if I have to give a title for volume 2, I would prefer giving two titles because two of the chapters would come under the title optics, and later chapters would be clubbed together to be called as modern physics. I used the term classical a few minutes ago. So classical physics and modern physics. Because whenever something is old or classical, there would be something always modern. So in what way these two things differ from each other, or what is the boundary that segregates classical physics with modern physics? That is the initial understanding that we should have, what I feel like. So I feel it is better to think about that and later jump on to that. But before that, electromagnetism. Should we dedicate an entire volume on electromagnetism? Is it that important? Because whenever we talk about framing the syllabus or learning in the curriculum, whatever that comes for a longer time is naturally important, because that is the basic idea that we have when we learn a subject. If they are going to devote an entire volume for electromagnetism, is electromagnetism a very important topic in physics? Yes, it is. So we are able to communicate with each other through this technological marvel because we have technology. And the entire technology, the so-called technical marvels that we enjoy in the modern era, comes, or it has its foundations or roots in electromagnetism. Understanding about the electromagnetism helps us to create gadgets. Motors, generators, everything, they are based on the principles of electromagnetism. So understanding electromagnetism is very, very vital in order to know how things work in the modern era, and also to make our lives a better one. We have a lot of sophistications in our life, in the modern life, and they are all possible because of understanding the fundamentals of electromagnetism. So that is why we would say electromagnetism is very, very important. So in the electromagnetism, the core idea of electromagnetism lies in understanding the electric charge. Of course, there is electro and magnetism. The property of electricity and magnetism are going to be dealt in this entire volume. But when it comes to electricity, the primal thing that we should understand, or we should have a basic knowledge of, is going to be electric charge. So that is the foundation. That is where we have to start the idea of electromagnetism. Right. So I was asking you a question, right? So if we call something else classical physics and something else as modern physics, what is the boundary that segregates these two? Which idea that tells me that I could differentiate a physics, a single idea of physics, a single field of physics into two categories? How could I do that? So the idea that separates these two is the understanding about atoms. Do we know about atoms? Yes, but not quite a lot. Until the late 19th century, we were having only a fundamental idea of atoms. Though atom comes from the name atomos, which has been used millennia ago, we were not aware, or we were not able to explore a lot about the reality of atoms. So as technology improved much better compared to the rest of the humankind's history in the late 19th century, followed by a tremendous explosion of technology in the 20th century, and which we are enjoying in the 21st century right now. So because of that, we were able to understand a lot about atoms, and understanding more and more about atoms and its existence and its properties, we are able to understand that the universe that we were assuming to be entirely works in a different fashion. So whatever we had been knowing till then, till the understanding about atoms came into us, we segregate and put them into a title called classical physics, which is also popularly called Newtonian physics, like I was saying, because Newton's contribution is immense on that part. Right. So understanding about atoms, and that is directly connected with this modern physics. I'm not talking about optics, because optics is part classical and part modern. And when we talk about understanding about atoms, it is purely going to give an outcome for modern physics. So when shall we talk about the timeline of modern physics? Yes, about atoms. So when we start to understand about atoms, we were able to understand, we are able to know that the modern physics era begins in the late 19th century. To the closure of the 19th century, we would say the modern physics was born. And in the 20th century, it took a shape. Right. So this is a brief introduction of what's going to be about the volume 1 and volume 2 of 12th grade physics. Now let us jump into volume 1, the separate units and titles. What are the things that we are going to learn and what we are going to explore? So that is going to be volume 1. So when it comes to volume 1, these are all just the unit titles that I have written. I haven't written anything different here, so it's going to be the same. What I would like to indulge myself in is the order of these units. Why should we learn the first unit as the first unit? We have never asked such questions, right? It might sound strange to you, to some. So when we talk about titles, is there a connection between the units that we are going to learn? Yes, certainly. Can we jumble this? No, certainly not. So electrostatics, this is going to be the first unit that we are going to discuss in the volume 1. Like I said, the idea of electric charge is the foundation and fundamental when it comes to understanding about electricity. Electromagnetism is put together. And when we talk about electricity, we need to understand about electric charge. If I ask you a question, what are the electric charges? What are the different types of electric charges that you know? You would easily come up with an answer because it is taught to you in lower classes. Right in your 8th grade or 9th grade, you would have studied about there are two different types of electric charges, positive charge and negative charge. And even you could come up with an example for each type of charge. When I ask you, give an example for positive charge, you would say, yes, proton. And when it comes to negative charge, you would say that it is going to be an electron. So we have been learning about atomic models in basic chemistry as well as in physics. So we are aware that there are positively charged particles and negatively charged particles. So broadly classifying the electric charges, we can talk about two different types of particles alone. One is going to be a positive charge and the other one is going to be a negative charge. We all know about this, but do we know what an electric charge actually means? No, we don't know. We are going to learn about that electric charge, its types, its properties in the first chapter, electrostatics. Along with the idea of electric charge, we would extend the idea to know the concepts of electric field, electric potential. We will be learning about them more. Electric flux. So these are all fancy titles that you might think of now, but once we understand what they are, they will become easier. So when it comes to electrostatics, understanding about the electric charge, when I say the title electrostatics, so statics is a familiar title to us. Remember, you would have studied something about statics, at least an introduction to it, in kinematics chapter. Because in mechanics, we bifurcate mechanics into two broader categories, one as statics and the other one as dynamics. And we would have even learned the definition for statics and dynamics, something like this. Dynamics is a study of objects in motion, and statics is the study of objects at rest. This is the one-line definition that you could come up with, right? Hope you remember. If I just borrow that idea and use it here, electro here refers to charges basically. And when I talk about electrostatics, I come up with something that is meaningful. So when I talk about electrostatics, I'm going to talk about charges that are at rest, because it's statics, right? So statics is a study of objects at rest, and here the object happens to be the charge. So here we are going to concentrate on the properties of charges that are basically at rest. So will a charge move? Yes, under favorable conditions, under favorable channels, a charges would start moving. And when there is a continuous movement, we call it as a flow. When charge starts to flow, it is no more called a charge. We give a name, current, electricity. Electricity is nothing but the flow of charges. We have studied in our 9th grade or 10th grade even about that. And now we are going to have a hierarchical compilation of the ideas. We are going to see logically how they are placed one after the other, the foundation of the ideas. So if in volume 1's first unit we are going to concentrate on charges which are at rest, in the second unit of this same volume we would talk, or we would concentrate on what happens when a charge is going to flow. So we are going to talk about current, electricity in the second chapter, second unit to be precise. In that second unit, we will be talking a lot about current, electricity, its basic properties. Whenever we talk about the flowing, we talk about charges, right? Charges are basically particles. So if a particle starts moving, it would certainly have a velocity. It would have an acceleration, because every moving object has one. So in that case, we would be dealing with what is going to be the velocity of that flowing charge, and how the properties of the charges are going to change or even dilute when it starts moving from one place to another. So in which channel it is going to move, what are all the requisites when charges are going to move from one place to another. So we will be dealing all that in the current, electricity. So a continuation of one lead of this current, electricity comes as the second part of your third unit. So I'm talking about the connection between the units, right? Ideologically, the connection between them. The basic, based on ideas, how they are interconnected with each other. So the magnetic effects of electric current. So let us forget for a moment about the magnet and let us talk about the effects of electric current. This title seems a little different, right? It is seeming to me like a topic given for a general essays that we come across in language papers, effects of electric current. No, we are not talking in that sense. So when we talk about electric current flowing, so let us talk about a very simple scenario where I'm going to use an electric bulb connected with an electric source, be it a battery or your power line. When you connect it and when you switch on the power, naturally the bulb glows. Let us say we allow the bulb to glow for about 30 seconds or 1 minute even, switch it off and you touch the bulb. What do you feel? Oh, it's a little hotter, right? So when we talk about giving power to a bulb, what is the basic idea of that? What is the basic need? Yes, I give electrical energy to it because I wanted light energy from the bulb. But along with the light energy, it has also given some heat energy along with it, which I don't prefer, but I cannot avoid it. So when electric current passes, let us say an electric current is passing through a wire, a conducting wire, because we always need a wire for electricity to pass. When we touch a wire without the insulation layer or the material that is over, when we touch a bare wire, we are able to feel the heat, because we understand that whenever electric current flows through a conductor, it heats up the conductor. That is the heating effect of electric current. So whenever electric current flows in a circuit or in a power line, it has some side effects, and those effects are going to be learned by us in these two chapters. So in current electricity, we will reserve that heating effect of electric current, and later we will move on to magnetic effects of electric current. Since we are talking about electromagnetism, there is a close relationship between electric phenomena and magnetic phenomena. They are interconnected. We will deal all about it in detail as we move on to the topics individually. So right now let us understand that there is another effect of electric current, that is going to be magnetic effects of electric current, which we would discuss in detail, because I was talking about gadgets and stuff like that, right, earlier while I was introducing the idea of electromagnetism. So this magnetic effects of electric current is the fundamental idea where we exploit where we exploit a lot about magnetic effects of electric current. That is how we understand. And the first part, the missing piece of the electromagnetism. So we in the first chapter talk about electricity a lot, and even in the second chapter, electric charge in the first and electricity in the second, and we are not touching about magnetism. Magnetism is a very fancy topic since childhood, right? No one would have crossed their childhood without playing with a magnet. Yes, we are all fans of magnets, right? So when it talks about magnetism, we are going to learn from the fundamental. What are the properties of magnetism? What are the different types of magnets? What are the basic properties of magnets? And how do we understand those properties? How do we calculate? How do we define it? All those come under the idea of magnetism. And followed by it would be the magnetic effects of electric current, because that would be the appropriate way to connect these ideas together. Because in the first two, we are talking only about electric charges and the flowing electric charges, which happens to be the current electricity. But if you want to club the electric idea with the magnetic idea, we should have some fundamental knowledge about magnetism, which we are dealing in the first half of the third unit. Followed by it, magnetic effects of electric current would be an appropriate place to place it. So after this, we were talking about two, right? One is the heating effect of electric current, and another I was talking about magnetic effects of electric current. Apart from it, there is a third important effect of electric current, which we call it as chemical effect of electric current. Whenever we take a battery, the one which we use in our remotes and torchlights, right? When we take a battery, a dry cell, to be precise, technically called dry cell, we always have a positive and negative marked in it. And if I ask you what is the type of energy that is stored in there, you would come up with an answer. It is stored in the form of chemical energy, right? So whenever electricity passes through such circuits, such systems, they tend to make chemical changes. They tend to create some effects chemically, and that is what we call it as chemical effect of electric current. So you would have learnt about electroplating and stuff in chemistry in your 9th grade and 10th grade, and that is nothing but the chemical effect of electric current, which we would deal later. So from moving on from the volume 1's unit 3 is another important aspect of electromagnetism, because EM is actually an acronym that I use for simplifying my writing. So EM should be read as electromagnetic induction, and AC is not the air conditioner, it is the alternating current that I am specifying here. So we have been familiar with two different acronyms, DC and AC. A moment ago I was talking about a battery, right? So what is the current that battery is able to provide? We were even talking about the positive and negative markings there, because the positive terminal remains as positive terminal and negative terminal remains as negative forever, right? Until the battery dies down, it is going to remain there. So if I talk about direct current, that is what DC means. And if it is going to be an AC, we name it as alternating current. We explain that as alternating current. So what is going to alternate in that current? We are talking about the direction of current. When we talk about direct current, it is going to be a unidirectional current, because we know right from our lower classes that current always flows conventionally from the positive terminal to the negative terminal. That is where the direction of current is marked to be. So if I talk about the positive terminal and negative terminal, which is going to be a constant throughout, I know that the current direction is never going to change. And that current source is called the direct current source, or the DC source. So in the first 3 chapters, we have been talking a little about electricity, current and all that stuff, right? So whatever we deal with up to the 3rd unit is going to be direct current. And this is the place, just after introducing electromagnetic induction, for which we need to thank this man, the Michael Faraday, the painting that I have by my side. We have to thank him, because if not for him, we wouldn't be able to understand electromagnetism in its fundamental shape and form. So after electromagnetic induction, where we would be talking a lot about Michael Faraday, his 2 experiments and his laws. Michael Faraday has contributed both for electrolysis as well as for electromagnetism. For here, we would stick on to the idea of electromagnetism. Faraday's laws of electromagnetism would be dealt in detail. And if you understand this concept, there is a connection between the magnetic effects of electric current and EM induction, because they give you the foundation for the idea of electromagnetism, understanding the application part of electromagnetism. How do we exploit that basic idea of electromagnetism for the betterment of our everyday life? And alternating current gives you a basic idea of what is an AC first of all. So because we talk about alternating current, it is not going to be in the same direction. If so, I would have called it as direct current or unidirectional current. So if it is going to alternate, in what form it is going to alternate? So AC could also be termed as, if I talk that as unidirectional current, here I could even name it as bidirectional current, because it is going to flip its direction for every half of the cycle. We will deal with the cycles and other stuff later. For now, you understand it is different from DC. AC is different from DC. Even AC, we have learnt in our 10th grade or 9th grade, we would have learnt about AC generators and stuff. So we would just extend the idea of it in a detailed manner in this chapter. And the last unit of volume 1 happens to be electromagnetic waves. In the beginning of this introduction in this class, I was talking a lot about electromagnetism and its relation with the gadgets and modern life and technology, right? So when we talk about technology, when we talk about gadgets, how do gadgets communicate with each other? Through waves, through electromagnetic waves. So we have been knowing a lot about different names of waves. We have been knowing about X-rays, we have been knowing about radio waves, we know about light rays for an instant, right? Light rays are very familiar to us because right from our childhood we have been knowing about light. So all these come under one umbrella called electromagnetic wave. So in this chapter, we are going to learn about what is meant by an electromagnetic wave, how it is generated. How can you generate electromagnetic wave, an electromagnetic wave of a desired frequency or wavelength? How was it first done historically? Hertz would come into the play. And later we will try to understand how to classify these electromagnetic waves, because it is a very broad spectrum. Initially it was thought to be just one type of wave, but later we understand it is not just one, but we have a broader spectrum of waves. And we would learn a lot about electromagnetic spectrum in this unit, and we will talk about the advantages or the properties of those waves and how those waves are connected with our everyday life, in which area they are utilized or they are used. The advantages and applications of those electromagnetic waves will be dealt here. And more importantly, there is one topic that we should be concentrating here, because we would be talking about Maxwell's equation. I was thanking Michael Faraday by my side a few minutes ago, and we should thank another person for this entire electromagnetism, because he put that in a nutshell. And that guy is James Clerk Maxwell, whom we will be meeting in the electromagnetic waves chapter. So we will be learning about the fundamental equations, the electromagnetic waves, to be precise, electromagnetism in total, as Maxwell's equation. There are 4 fundamental equations. The 4 fundamental Maxwell's equation will be dealt and introduced in the last chapter. So this is going to be what it is in volume 1 of the 12th grade. Well, this is a broader introduction to what we are going to learn. Remember, learning is a lot of fun. It's not going to be a tedious process. We can enjoy a lot, especially when learning physics, because what is around us is what we are going to explore scientifically, that's all. So if you have a natural curiosity to know what's happening around you, and sometimes what is happening inside you even, physics has got a lot of answers, and if you are for it, this is the place for you. Well, just with this, I close the introductory video of this, and we will continue to meet in regular intervals. So stay with P for Physics, subscribe it. If you have got any comments, just place it in the comment section so that we communicate with each other. And if you like this video, press the like button and don't forget to tell your friends. Thanks a lot, friends. This is Joe signing off, and this is P for Physics. Let us stay connected and let us learn and enjoy physics. Thank you.